So we are on lesson 3 today, which is about exploring exponential growth. We've kind of been doing this unit a lot slower than I would in the past. So it's a lot of like the first few lessons at least, recognizing patterns, noticing things. So that way when you relate it to the vocab that we'll introduce to you in a later lesson, you can make those connections and actually remember it long term. So that's a lot of the reason why we do this. So like then when you take your ACTs or your ACT Aspire, and we talk about exponential functions, you can think about like that genie in the bottle or that bacteria splitting into cells and all of those things. But today the target is just to explain connections between an equation and a graph that represents exponential growth, and then interpreting pieces of that equation. So I'm recording now, just like always. So remember, check the slides if you're ever absent. Same thing when I'm absent, there's always a list of things for you to do in the slides, and like usually a video to watch or a note sheet to submit. So if you didn't do that for whatever reason, maybe you think some days are like recess, I don't know. You're still responsible for turning that in. All right, so that's on you for making sure you can get that right on your test. Puzzle piece for today's lesson is Unit 5, Lesson 3. Same procedure as always for those. And you do have a quiz today over Lessons 1 and 2. So that will be toward the end of class. It's really only 5 questions, so you only need like 20 minutes max. No one had trouble finishing, except for like there were some troubles with Schoology. So just if that happens, just keep trying until it works. It didn't affect too many people, and usually it works after a while. So still didn't have issues with anyone finishing. All right, any questions at all? All right, so then now onto the warm-up, which is also printed on your paper. They aren't always printed on your paper, but feel free to take notes. So if you don't remember how we do the math talks, there's usually a problem on the screen. The task is to try to do it without a calculator and without any like scratch work, if you can. And then when you have the answer, put a thumb up. And once I have enough thumbs up, I'll call on someone to share a strategy. Usually there's more than one strategy to solve. The more that we can come up with, the better other people can learn from it too. All right, so the task today is to rewrite each expression as a power of 2. So first one is 2 to the 3rd times 2 to the 4th. Rewrite it as a power of 2. Then you have the answer, put your thumb up. I was recommending all things. You got into your text okay? Yeah, okay. All right, I'm looking for those thumbs. Supposed to be silent. Landon? All right, 2 to the power of 7, table 7, quiet. Anyone get something other than that? Is there something else we could write that would also be correct? Landon? Oh, okay, sure. That isn't writing it as a power of 2, but I'll accept it. That still wouldn't be a power of 2, but still I'll write it down because that's also a good observation. 4, 5, 6, 7. Anyone else have it as written as a power of 2, but maybe like slightly different? All right, so here's what my first hour said. 2 plus 4. Good. 2 to the power of 3 plus 4. And then, of course, 3 plus 4 is... So this is the most simplified answer, the 2 to the 7th power. But I also like this one because it shows you the rule, which if you don't remember your exponent rules, that's why we have like a little cheat sheet for you already filled out. on your paper. All right, we'll really dive into exponent rules and make sure that you know them without having to use this cheat sheet. But in this unit, it's fine. You can use a cheat sheet. There's really a few important ones that we'll look at today, but like the product rule is what we used for the first one. When you have the same base, so the same big number multiplied together, you add the exponent. That's the rule. So if you're not familiar with the words I'm saying, like a base and an exponent, maybe write this down. If it's 2 to the third, 2 would be the base number, and 3 would be the exponent. What do exponents tell us to do? Multiply the base number by itself, however many times the exponent says. So like the 2 to the power of 3 would be like these 3 2's multiplied together. The 2 to the power of 4 would be these 4 2's multiplied together. And of course, if you count them, there's 7 total. You could condense that to 2 to the 7. That's why it works. Miss Medina. I'll send her to you. No problem, bye. Abigail, G, you're needed in 11:18. Can you remember that, or do I need to write you a pass? Yeah. Oh, okay. So, all right, moving on. Here's the next one. When you have the answer, just put your thumb up. Don't say it out loud. Don't share it with each other. Let's see like how many thumbs we can get. Hopefully, maybe after seeing the first one, you can figure out the second one now. All right, Ryan, is that a thumb up? Okay, what did you get? 2 to the power of 6. Anyone get something different or write it differently? Brandon? All right, 2 to the power of 5 plus 1. Anyone get something different else? All right, so both of those are written to the power of 2. Good job. This is your simplified answer. The first one, the second one shows you the rule. So that's what you're doing. What is the exponent implied to be if it's not written? 1. All right, so that's why it wasn't just 5 plus 0. If the exponent, or if this is there at all, it's to the power of 1. If it wanted it to be to the 0 power, do you guys know what anything to the 0 power is? 1. That's a rule. Anything to the 0 power is 1. It's also on your little menu of rules. So that's your 0 exponent. So even like 1,000,000 to the 0 power will equal 1. Try it out on your calculator if you ever forget, but that's what it is. All right, so that's why this is not to the 0 power, because then this base number would have been 1. Questions on the first two? All right, then here's the third one. 2 to the 10th divided by 2 to the 7th. Rewrite it as a power of 2. Put your thumb up when you think you have an answer. If you're confused, try looking at your cheat sheet, see if you can figure it out from there. All right, Jalen, what did you get? 2 to the 3rd power. Anyone get something different? Anyone write it a different way, or can write it a different way? Brandon? 2 to the 10 minus 7. So that is the rule. If we are dividing stuff with the same base, so they're both, so the base number is 2. Then what you do with the exponent is subtract them. So that's the quotient rule. So here's an example with variables, but that's the rule. The way that I remember it, so like product, normally like a time symbol looks kind of like a plus symbol. A quotient rule, the division symbol looks kind of like a subtraction sign. But this is what you're doing with the exponent on those at the same base. All right, so 10 minus 7 is 3. Last one, hopefully seeing some more thumbs. Because your thumb is up doesn't necessarily mean I'm gonna call on you, but you can try this out. Right? Try and pick someone different. So if I already picked you, put your thumb down. We can wait until someone wants to get out there. It's all right, even if it's wrong. Brian? 2 to the 8th power. Anyone get something different? Could anyone write it a different way? Hayden? Of 9 minus 1. Good. So that one shows you the rule. I like that as like scratch work. But this is simplified version. Remember, if it's not written, the exponent is 1. Subtract them according to the quotient rule. So there you go. Questions on the warm-up? Again, exponent rules aren't huge in this unit, but this unit is exponential functions. So you'll see like some of those patterns in there. We're really going to focus on exponent rules like in the next unit. So just be prepared. These will show up again. And usually they expect you to know them without having a menu in front of you. All right, now on to today's activity. So in your groups, complete the table and take advantage of any patterns that you notice. So complete the table, make sure everyone in your group agrees. If you disagree, talk it out. So I'll assign a reporter in a little bit, and then also answer 2 and 3 on your paper. All right, so let's start with table 4 today. What goes here where my mouse is for the table? Sorry, I put the numbers away. Oh, yeah, you guys. 9. And if you guys disagree at any point, make sure you speak up. Don't let us get too far in if you think something's wrong. Table 5, what would go here? Table 6, what would go here? All right, anyone disagree at all? Exactly. Yes, of course. So a big giveaway here is this that's written on the side. Normally it's X and Y input output, but this one, since it also has an X in it, tells you like what is happening to the X instead of trying to make you find it yourself. So when X is 4, 3 to the 4th power in my calculator is what? 81. It says that right there. And I don't expect you to know most of the exponents. Usually like 3s and above, people don't know off the top of their head. So feel free to use a calculator. 3 to the power of 4. These are the buttons you would press. 3 base number, you can press this, and once you type in any number, and I get 81. Other calculators usually have a button that looks like this, like an upward arrow. And if I was trying to do 3 to the power of 4, I would press 3, this button, 4, hit the equals, and it would still give me the 81. Question?
This second.
Well, that's fine. You could write it in if you want, but you'll see what I want you to see. So good. Then when you keep going, the next X value, I think was 3.
Yeah.
So 3 cubed is 27. That's what they're doing each time. So then 3 squared, because we're putting the 2 in for the exponent, gives me 9, because it's 3 times 3, the exponent tells you to multiply it by itself that many times. 3 to the first power is 3. And then anything to the 0 power is 4. Good. So that fills in the table. These are pretty unrelated, but the goal is to try to get you to see certain patterns. So let's do those now. When she comes back. Table 7. Looking at the first one, this one is on your paper, the 9 to the question mark times 9 to the 7 equals 9 to the 7. What must that question mark be, table 7? This one. Given what you know about exponents now, what would that question mark have to be if it's times 9 to the 7 equals 9 to the 7? 0.
See what you chance.
I said 0. Okay, 0. Anyone disagree with that?
I agree.
So let's see. 9 to the 0 times 9 to the 7. What's 9 to the 0 power equal? 1. And then times by 9 to the 7. Anything times 1 gives me the other value, right? So you're not going to add 0 plus 7 if you were thinking that. I mean, I guess you could, but then it gives you the answer. So you could do that, but that must be true since it equals the 9 to the 7. Does that make sense? All right. The bottom one isn't on your paper, but just look at it real quick. 9 to the 12 over 9 to the question mark equals 9 to the 12. What must that question mark be, class? Shannon?
That's 12.
Good guess, but it is not 12. Because then that would equal 1, not 9 to the 12. Make sense? It would be 0. So we would want the bottom portion to become 1 if, it equals the numerator after dividing. But the only way to get it to become 1 is to put 9 to the 0 power. All right? Question? All right, these I hope are easy. Let's see. Table 8, what's 5 to the 0 power? It is. Did you say 5? It is not. Let's see. You can always throw it in your calculator, see if you don't know. 5 to the 0 power is anything to the 0 power is 1. So go back and put that in your notes. 5 to the 0 power is 1. 2 to the 0 power is 5. All right, good. Questions on that? All right, now let's relate it to some of the situations we've been talking about lately, like bacteria reproducing. So that's the next part. So in biology lab A, 500 bacteria reproduce by splitting. Every hour on the hour, each bacterium splits into 2 bacteria. So splitting into 2 would be what operation? Not squaring, multiplying by 2. So if it splits into 2 bacteria, whatever value I have, I'm gonna times by 2 to get the next one. Or you could come up with another way that might be easier, instead of timing 2 each time to get to the next one. So do that within your tables, complete the table that's on your paper. And try to come up with the last one too, even though it says P hours. That just means give me like an expression that will help me find any value of T. So hopefully you see the pattern. All right, I'll give you 2 minutes to start out with. I try to get to every table, but sometimes I forget, so we'll, try to spread the love, table 2. After 1 hour, how much bacteria is there? 1 table 2. Sorry, what did you say, table 2? 1,000? 1,000. And then again, class, if you disagree, just speak up before you let us get too far. Table 1, what is it at 2 hours? 2,000. Table 3, what is it at 3 hours? Let's see, we have E, L, and N. So closest to the letter A would be L, so Luke, wait. All right, if the rule is that we're splitting into 2 cells every hour, and I have 2,000 at hour 2, how many would I have in hour 3? Say 3,000. Class,
Wrong.
what's wrong with it?
Well, it's supposed to double it. Every bacteria splits every hour, so it'll make it 1,000.
4,000. All right, but not bad. I mean, gotta learn. Some people probably thought that too. Table 4, what would it be at 6 hours? Class?
Because it's getting, they're like, and multiplied by like one.
So I have 62,000 on the board. Anyone else have something else? Did you say 62,000? Well, I can tell you 8,000 is not correct, Wrigley. 32,000. So let's see.
I'm at 32,000.
Okay, that's what I was thinking. So here's why. The hours are not going up by 1 each time, right? So yeah, easy thing to miss. A lot of people miss that right now. So it jumps. So you have 2 options. You could either keep the pattern going, like off to the side of your paper until you get to 6. Just times 2 each time, or you could come up with some sort of equation, I guess. So we can't really come up with one for the first one, that's what we started with. But to get to hour 1, if it doubled, we times it by what? By 2. So if it doubled, we times it by 2. Another hour, we're taking what we started with and timesing it by another 2. Isn't that 500 times 2 times 2? Isn't that 2,000? So then hour 3, it would be 500 times what? Good. So then for this one, hour 6, I could do 500 times 2 times 2 times 2 times 2 times 2 times 2, or what's a shorter way of writing that?
Oh.
2 to the 6th power. I could also condense the previous ones too. I could do 2 to the 3rd power. 2 to the 2nd power. And this one is still 2 to the 1st. But do you see like the pattern? What are we noticing? In each situation, all we are replacing is the exponent. So like this one's 1, that one's 1. This one's 2, that one's 2. This one's 3, that one's 3, this one's 6, that one's 6. So really all I have to do is put that in my calculator. And now I can solve it for any value of x. So 500 times 2 to the 6th power is 32,000. Make sense? All right, now the bottom one is a little more tricky. Anyone think that they have it? Jalen? Okay, I have 500 times 2n like that. So the n in the x box, or like, I think I know what you mean. So like the power of n, you mean? Yeah. Okay. Now, since they're using t's, and that's like what's changing each time, I'm gonna put a t there instead. Because I think in this one, they want n to be the number of bacteria and t to be time in hours. But doesn't that make sense? For each one, the input is going on the exponent, right? That's the pattern. The starting amount stays the same. How it's increasing is staying the same, like it's doubling each time. But the exponent changes. So questions on that? All right, this part C we'll just do together real quick. It says use your equation to find n when t is 0. So where that t is, I'm going to replace with what? With 0. Make sure we're paying attention. It's right in the problem. All right, it says find n when t is 0. N is the number of bacteria. What is the value of n when t is 0? 500. How do you know?
N represents the bacteria.
Okay, give me more. Why else is n 500 when t is 0?
Is it because
Peyton? Because it makes the 2 to the 0 power 1. And then 500 times 1 is 500. Additionally, t represents what? The exponent, which represents in the problem, no, the hours. That's already in the table. At 0 hours, we have 500. So at 0 hours, or 0 of your exponent, that also represents your starting amount. That makes sense? So now apply what we just figured out for what each represents to this equation. So this is biology lab B. They have a population of single-cell parasites also reproducing hourly. Explain what the number 103 would mean in that situation. So look at it in your groups. Come to an agreement. What does 100 represent? What does the 3 represent? And be prepared to share. This time the reporter will be whoever's name is closest to the end of the alphabet. So let's start with table 8. Given what we just talked about, hopefully we're noticing some patterns. If not, this will hopefully make you see it more. What would the 100 represent? The starting amount of parasites. All right, just like how in the other equation, the 500, the constant, the number that's alone is your starting amount. So kind of recognize that from here on out. The 100 would have to be the starting amount. And then what would the 3 represent? Table 1. It represents that it triples, whereas the other one doubles because the base is 2. So we are timesing by 3 each time. Also call that growth rate. So the fact that it's a 3 means that it's tripling. Otherwise, that is your growth rate. Questions at all so far? All right, so good. I just want to show you the next one. You can copy it down on your paper. It is in Schoology if you need to see it better on like your own computer screen. But the next part is to graph both labs, right? So given like an input-output table, these are my 2 equations. So like here's for lab A, here's for lab B. Making a table of values is a great way to know like what your coordinates will be. So it says plot it when t is 0, 1, 2, 3, and 4. So my x's would be 0, 1, 2, 3, and 4. Plug it into your formula. Whatever your calculator says would then be your output. And then you put them on a graph. All right, we'll really look at graphing another day, but just to compare them. So like which lab starts at a higher amount? Lab A. It starts at 500. This one started at 100. So like lower on the graph. Which one grows at a faster rate? That might be a little hard to tell, but which one? B. You know that because this one tripled, whereas this one doubled. Even though this one started at a smaller amount, eventually it does overtake the other exponential function. Like this one's higher than that one, ever so slightly, because it's growing at a faster rate. Questions at all? All right. You do have, well, we do have our quiz that we're going to take because that only needs the last 20 minutes of class, maybe even less than that. But your puzzle piece for lesson 3 has been available since yesterday. I wanted you to try it. I don't know if some of you did or didn't. I haven't checked, but I also want to give you like a little more help with it. So this lesson and that practice have the same goal, which is basically to make the equation of exponential growth. But for these word problems, I'm going to give you a little more help. So I was going to give you this on paper, but then since I was absent, I figured it'd just be easier to give it to you in a puzzle piece. But these are the same questions, just so you know. So I'll probably give this to you tomorrow because we're going to take our quiz here soon. But I also want you to write this down on your paper somewhere. So the formula for exponential growth will look something like this. Y equals A, parentheses, 1 plus R, so that's a 1, to the T power. All right, so write that formula down. Y equals A, parentheses, 1 plus R to the T power. A would be your starting amount or initial amount. Just like how it was in our lesson today. It was something times something with an exponent. R would be my growth rate. but it has to be written as a decimal, so make a note of that. And T, guess what T stands for? What did it stand for in the lesson today? Hours. It's gonna represent time for everything. Because exponential function usually, well, I mean, depending on if it's growth or decay, but right now we're looking at growth, will grow over time. So depending on how much time has passed, will affect how much it grew. So yeah, that will help you with your practice in case you were having trouble. So like for this one, my starting amount is $1,400. In parentheses, it's 1 plus the growth rate, which it increases by 9%. I have to write that as a decimal though. What is 9% as a decimal? Anyone know how to convert percent to decimals? Just divide by 100%. And that gives you the decimal. So it would be 1 plus 0.09. And then to the T power, however much time has passed. So in this one, it's 25. You put that entire thing in your calculator, exactly how it looks, all at one time, unless you want to do order of operations. And so that was 1,400 parentheses 1 plus 0.09 to the 25th power, just like that. Parentheses matter. That's a pretty big number, right? But that's the answer. So for that one, and I'm pretty sure we were talking about dollar amounts in that problem. So dollar amounts go to 2 decimal places. This would be my answer for the first one on your practice. All right, hopefully that helps in case you were a little confused. We'll look at it more tomorrow. So try it tonight. Come prepared with your questions tomorrow. Now we're going to move on to our quiz. So any questions at all? All right, so then moving on.